In this problem, we're going to subtract fractions using the same idea that we used before with fractions involving numbers. That is, we have to first rewrite each of the fractions so that they have the same denominator, and then we'll just subtract the numerators in a normal way. This one will involve some simplification with algebra. We have to be very careful with our distributive property, but other than that, it's the same sort of problem. So the first thing we do is identify that the common denominator here will be the product of these two denominators. So my common denominator that'll work will be the product of the two denominators that I have available. So product of x minus 2 and x plus 3. That's my goal for a common denominator, and there's no reason to multiply that out. So in order to rewrite each fraction having that common denominator, I have to use our equivalence. So I'll take the fraction 7 over x minus 2. That's my first fraction. And I'm going to multiply the top and bottom by x plus 3. As long as I multiply the top and bottom, we know that that's an equivalent fraction. It doesn't change the value of the fraction. And so when I multiply the numerator, multiply the denominator, I will multiply out the numerator because I know I'm going to have to subtract in a second and simplify. So I might as well go ahead and multiply this out. 7 times parentheses x plus 3 is going to involve the distributive property, so I'll have 7 times x and 7 times 3. So that's my numerator, and my denominator is, of course, the product of x minus 2 times x plus 3, which was my goal. Remember, this is my goal of my common denominator. Similarly, I'm going to take the second fraction, the 2 over x plus 3, and now multiply the top and bottom by x minus 2. The reason I'm multiplying top and bottom by x minus 2, remember that I'm motivated by trying to make my denominator here be the common denominator. So if I multiply x plus 3 times x minus 2, then I'll have the common denominator as my new denominator. But I have to do the same operation, same multiplication to top and bottom in order to have an equivalent fraction. So again, I'll use the distributive property on the top, so that's 2x minus 4. Again, multiply 2 times x and 2 times minus 2. And my denominator will be the same thing I had before. So x minus 2 times x plus 3. The order here doesn't matter. Okay, so I have my two fractions. I have rewritten them as equivalent fractions with the same denominator. So now, when I take fraction number 1 minus fraction number 2, it's going to look like this. I'm going to have one big fraction. The denominator is going to be the common denominator. That was the whole point. And in the numerator, I'm just going to have the subtraction of the two numerators that I had. So the first fraction's numerator is 7x plus 21. And notice how I'm putting parentheses on this. I mentioned that when we use the big fraction bar, we don't usually use parentheses, but the parentheses are implicit, meaning that we don't put them on just because they are sort of in the way. But when we write an expression in a numerator or denominator, like this expression in the denominator, we mean that that 2 is divided by the entire quantity x plus 3. So if I'm trying to manipulate it outside of the fraction bar, I need to use parentheses around it. So the parentheses are implicit in a fraction, and when we want to work with the two pieces explicitly, I need to add parentheses. So this is a subtraction problem, and so now I can just do 7x minus 2x is 5x, and I have plus 21 minus negative 4. So 21 minus negative 4 is the same as 21 plus 24, which 21 plus 4, so that's 25. And the denominator is x minus 2 times x plus 3. And since it says to put the fraction in factored form, it may actually want this last step where I can factor the numerator. It doesn't factor very interestingly, but there is a common factor of 5 in each piece. So I could rewrite the numerator there as 5 times quantity x plus 5, and the denominator would still be x minus 2 over x plus 3. I'm not sure if the computer will accept that answer or if you have to do that. But either way, it's one more step.